Hello folks, so again we have a question. This time the question is of harmonic motion, or we can say it as a periodic motion, and it is useful for AS as well as A2. So it says that a trolley is attached to two similar stretched elastic threads. So these are the elastic threads. It is pulled to the left, to position R, certain position R, and then released from rest. So it is released from rest here. The graph shows how the kinetic energy of the trolley varies with displacement as it moves from R to S. So graph shows the variation of Ke. So here at R it is at rest, so that's why the Ke is 0, and it is goes from here to here. So at the midpoint the velocity will be the highest, so that's why the K is also highest, and from here to here the velocity will be lowest or 0, so K also is equal to 0. So now we have to find how does the elastic strain energy in the system vary with the displacement of the trolley. So we have to find out how the elastic strain energy varies. One thing that we have to remember is, in case of a spring system or an elastic body, what we have is the potential energy plus Ke is equal to constant, So though people have not studied periodic motion in AS, it is concerned with the law of conservation of energy. So that's why I'm doing this thing for you. So if it is so, then we have the potential energy is equal to some constant value minus Ke. So that means the variation of Pe will be exactly opposite to Ke, in such a way that their sum is equal to constant. So if so, let me go for this position. At R. At R, K is equal to 0. If K is equal to 0, P should be equal to that constant, and its value should be maximum. Since K equal to 0, this whole thing should have a maximum value. P should be maximum. So we have to go for those choices where the value of Pe or strain energy is maximum at this R. So in this manner, A and B qualify, but C and D, they do not qualify. So two have been filtered away. Then then at the very middle we have K is equal to maximum. So if K is equal to maximum, then P should have the least value. So in both of these cases they have got least values. So both of them still qualify. Now let us pick somewhere here. Let us go for this thing. So here the value of K is equal to 1, 2, 3, 4, 5 units. So here the value of K is equal to 5 units, and whereas the value of K is equal to 5 units. So in the same manner we have to find the value of P at the same point. So what happens here is, in choice number this we have K equal to 5, and P is equal to 1, 2, 3, and maybe it is 3. So 5 plus 3 is equal to 8. So here what we have is K equal to 5, P is equal to 3, so which means the total energy is equal to 8. So let's find whether the total energy is equal to 8 or not. So here K equal to 0, P is equal to 1, 2, 3, 4, 5, 6, 6.5. So K is 0, P 6.5 means the total energy there is equal to 6.5. So here also we have P is equal to 0 and K equal to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 6.5. So total energy is 6.5. But here what we have is, if I take this, I am having this 5 plus 3 equal to 8. So this also disqualifies. Let's go for B. So at this point I have got K is equal to 5, and I have here this P is equal to 1.5, giving the total energy as 6.5. So that means here the total is 6.5, here the total is 6.5, and here also the total is 6.5. So K is 6.5 and P0 means total 6.5. K is 6.5 and PE0 means total 6.5. Again here we have got PE 6.5 and KE0 is 6.5. So choice number B is the correct choice for this graph.